So let's start with very basic things first. Okay, so here generally our discussion starts from very basic, that is from atoms right now. So what do we mean by atoms? So before these atoms we need to discuss little more things, that is what? Matter. So what do we mean by matter first, tell me? See, it should be very like friendly class, it should not be like serious here. Okay, yeah, tell me. So tell me, what do we mean by matter? So it can be anything that occupies space and has some mass that can be feel or we can sense using our senses right now. Okay, something like, see here I have a pen. So it has some mass occupying some space, so it can be considered as matter. Okay, so now this matter is again classified into different ways. So matter can be pure form or it can be impure form. Okay, I can say it as a pure or it can be impure. So impure means what? See, pure, impure means what? See, if I mix two pure compounds, that will become, it's a mixture right now. See, it's a pure substance. If I mix two or more pure substances, we are going to get a mixture. So that mixtures are considered to be impure, we can say like that. Okay, so now these pure forms, I can say two things, two types, as elements and compounds. Something like here, when it comes to impure form, see, for example, sodium chloride is there. Sodium chloride is a salt. Tell me whether it is pure or impure. It is only one compound, no? One individual compound right now. So first of all, we need to know about elements and compounds. We'll go there. See, element means it is an independent existent. What is it? Independent. Okay, it means in the nature, if you are extracting like gold, you are extracting by mining and all. Okay, so now gold means it is an independent existent in the nature. Okay, so now gold is considered to be an element. Okay, similarly oxygen is there. Okay, now see, in the nature, how you will see oxygen means you are writing it as O2, you are not writing it as oxygen. Okay, see, in the nature, oxygen is existing in O2 molecular form. Okay, but what is the atomic form for that? O, just O. Okay, so this is atomic form. Okay, so now every atom has its own individual identity. For example, sodium atoms, if I say, sodium atoms are different from oxygen atoms right now. So but if I say element, sodium element, so now the combination of all atoms of one particular element have same properties. It means all sodium atoms will have same chemical and physical properties. Okay, so now what is the atomic number of sodium we are saying? 11, like that. Okay, and oxygen here 8. Now they have different number of protons, electrons, therefore they will be having different chemical reactions as well as physical properties also differ. Okay, so now what I am saying, elements means they are independent existing species. Okay, so now these elements again classified into three ways. What are those? Like they can be metals, non-metals, metalloids. Okay, so in the periodic table, it is a combination of all types of elements. Now how many elements are there in the periodic table? 118 elements are there. Okay, so everything, like every element has its own characteristic properties right now. Okay, so it can be metal, it can be non-metals or metalloids. Okay, we will discuss about periodic table also. Okay, this is completely about basics. Okay, don't think we don't know anything. Okay, you know now, like you are hearing this element word from class 6th. Okay, and the next, what about compound means? So is a compound is a combination, it's a fixed ratio of two or more elements. For example, water molecule I am saying. Okay, so it's a combination of hydrogen and oxygen, but in a fixed ratio. What is that fixed ratio? 2 hydrogen atoms and 1 oxygen atom. So it has a fixed ratio now. So the fixed ratio of 2 elements will be giving us compounds. Not only 2 elements, it can be 2 or more elements. The fixed ratio of 2 or more elements combined to give us a compounds. Okay, this is simple way of understanding. Okay, right. Are you able to understand this? Very basic things. Give some examples of compounds now. NaCl is a compound because it has a fixed ratio of sodium and chlorine. Okay, I am not saying exact ratio, it's a fixed ratio. Okay, tell me some other examples. H2O you are saying, yeah. Next, H2SO4, MgCO3, magnesium carbonate, all these comes under compounds. Now, when I ask about NaCl, what you told, it is an impure form. Now tell me whether it is pure form or impure form. It is a pure form. It's a fixed ratio of 2 or more elements combined to form one compound. Okay, so it's a pure form. Okay, if I say water, see, you are saying pure water and impure water. So what do we mean by pure water? It has only water molecules, nothing other than that. But if there is some other species present, then we are calling it as impure water. Okay, so if we have only water, it is a pure one. If there is any extra, for example, some salts are there in the water. For example, sea water if you take, sea water. So tell me whether it is pure or impure form. Impure. Why you are saying impure? Along with the water molecules, there will be salts like sodium chloride, magnesium chloride, some other salts will be there. That's why you are saying it as impure one. Okay, but water is a pure. You got this small difference. Okay, now let us study about impurities here. Okay, impure form means, see, let us mix water with sodium chloride, like you are adding salt. You are taking some pinch of salt and adding to the water. Now what happens? It will dissolve. Now properly it will dissolve. Okay, clearly you can't able to see whether it has salt or not, whether salt is present in that or not. Okay, so it means you are getting a homogeneous phase. It means, what do we mean by homogeneous phase? It looks uniform throughout the solution. Right now, so what, see, I used a new term here, solution I am saying. What do we mean by solution? It's a mixture of 2 or more components. Now what are the components we have here? Water, H2O plus NaCl. So one is considered to be solute, other one is considered to be solvent. So this combination is solution. Okay, so now this is a solution now. Okay, so now tell me whether it is homogeneous or heterogeneous. Homogeneous means what? It should have a uniform phase throughout. It means if you see this solution, it should look only one single phase. Will it be single phase or multiple phases? Single phase. Single phase means it should be either in the liquid state or solid state. Only one physical state should be there. So it is homogeneous mixture. Now tell me, I am adding sand plus water. What about this? Heterogeneous phase. Okay, now you got two things. One is homogeneous, another one is heterogeneous. Now this heterogeneous mixture is there now. You should not say it as a solution. Solution means what? It is a homogeneous mixture of 2 or more components is considered to be solution. So here I am writing homogeneous. Okay, so now what is meant by solution here? It's a homogeneous mixture of 2 or more components. Now can I say sand plus water is a solution? No, it is not a solution. But if I add like salt plus water can be considered as sugar plus water solution. Now it will dissolve. Now sugar will dissolve. Slowly it will dissolve and form a homogeneous mixture. That is nothing but sugar solution we are saying. Okay, you got very basic thing here. Okay, then next. It means, why I am saying this solution definition here, you already studied class 12th second chapter. What is that? Solutions. Okay, so there you have studied solution definition also. But I think now you got clarity like what exactly solution means. It should be homogeneous mixture. Now these solutions can be classified into different ways. See, solution means it's a combination of solute plus solvent you have studied. Okay, now here solute means it should be lower quantity, solvent means higher quantity. This is what the basic definition you have studied for IP exam. But actually it should be like solvent, solution, solvent, solution, solute. These are the three terms you are seeing now. See, if I ask you water plus salt, okay, salt or like NaCl salt you are saying, okay, So now NaCl, which form it is? Physical state of NaCl means a solid. Okay, now water will be liquid. Now what about solution? Salt solution? Liquid state, right now. Okay, so now you need to understand that how can we identify solute, solvent in the given components. See, in order to make this solution, you required one solute and another one is solvent. Out of these two, which is solute, which is solvent? It should be said with respect to their physical states, not with respect to which is major, which is minor. With what we should say? Physical state. See, what is our solution physical state? So which is having the same physical state as our solution? H2O. So that should be considered as solvent. Okay, it means our solvent solution have same physical state. So based on this only you need to identify which is solute and which is solvent. Do you got this very basic thing first? Yeah, next one. Okay. Next thing is, let us discuss about atom first. Okay, see, atom means, like, let us say atom. I am indicating atom with symbol something like X. Okay, let us say this is an indication for atom. Okay, so now what we know, you have studied about Bohr's model and all. So we have studied there, atom has some mass. Okay, now the mass of that atom will be concentrated at the center. Okay, so that center is called a nucleus. Okay, so nucleus contains what? Protons plus neutrons. Okay, so protons plus neutrons are concentrated at the center of the atom. Okay, around which the electrons are revolving, like that we have studied. Okay, so now mass of an atom given by what? Mass of an atom should be, see, generally there is a bag. So in this bag there are some apples, there is some bananas or some carrots or something is there. So what you will say if I ask mass of this bag, you should add like apples plus whatever the vegetables, fruits are there, you will be adding all those. Okay, here also what do we mean by mass of this atom means what you will say? Mass of protons plus mass of neutrons plus mass of electrons, you should say. Okay, but you know, actually when you compare the mass of electrons with the mass of neutron and proton, its mass is very, very less. It is almost like negligible mass. Okay, so that's way atomic mass is given with the help of mass of protons plus mass of neutrons. See, the mass of electron is almost negligible. Okay, so what we are taking only protons and neutrons. Okay, up to here it is clear. Okay, then next let us say this is the symbol to indicate atom, let us say. Now here I am representing something called Z. Okay, and here A. Okay, and here some place minus C. Okay, and here some number here. Okay, so now, so what I am saying, nitrogen atom, what is atomic number of atom? 7. So that atomic number should be indicated with symbol Z. Okay, so that should be generally, by standard methods representation. So wherever Z, there you should indicate 7. So Z indicates what? Atomic number. Okay, what about this air indicates? Atomic mass. Atomic mass. Okay, now what about this plus minus C I am writing? This is a charge. For example, you will be seeing sodium ion, fluoride ion, chloride ion, like that, sometimes positive and negative charges. So that should be here indicated as a charge. Maybe positive or negative. Now what about this XYZ here I am saying? So this is called atomicity. What is this? So atomicity means what? See, how you are writing? You are writing oxygen as O2. Okay, and ozone means O3. Oxygen atom means O. Only like this you are writing. See, here it is 1, here it is 2, here it is 3. So numbers are increasing now. So same element only, but its multiplicity is increasing. So like exactly how many atoms are there in the given molecule is indicated with the symbol atomicity. So like nitrogen N2 you are writing. Okay, so this is how the standard way of representation. Okay, up to here it is clear now? Yeah, okay, next. Okay, so now tell me, I am saying atomic number of nitrogen is 7. So now how can you calculate? The simple way of calculating its atomic mass. Tell me, how can we do that? Yeah. So it is almost up to first 30 elements. This rule is almost applicable. Okay. So what you will take is just see, nucleus indicates what? It contains what? Neutrons and protons. Okay. So whenever I say atomic number, this will be equals to either number of protons or number of electrons. What I am saying, atomic number will be equals to number of protons, number of electrons in that atom. Okay, so by default you consider atomic number is equals to number of protons for more clarity purpose. Why? Because see, I am writing nitrogen, like let us say sodium I am taking. What is its atomic number? 11. Now what about sodium plus atomic number? Yeah, so that's way. When I changed from sodium atom to its cationic form, like positive charge is there now, you should say it as a cation. So now what is happening? What is happening here? See, it is 0 charge, no charge here, neutral converting into plus 1. It means this process takes place by loss of electron. If this is an atom, from this if I remove an electron, so electron means what is a charge? Negative charge on electron. So if I remove that electron, what happens to that species? Now it is losing one electron now. See, and in one atom there will be equal number of electrons and protons. It means overall molecule atom should be neutral. It should be no charge. If equal number of negative charges, equal number of, it means it should be neutral. But what we are removing out? Electron we are removing. So now who will be more in that atom now? Protons. Positive charges will be more. How many are more? That charge you represent here. For example, sodium atomic number is 11. So 11 protons and 11 electrons. Okay, but we are removing out one electron. So now how many species will be there here? 10 electrons, 11 protons. Who is more? Protons. How many are more? 1. So write that positive 1 charge. Okay, like that. Okay, it means during chemical reactions, who will participate in the reactions? Only electrons. Protons will not participate. Only this outside electrons will be there now. So those electrons will take part in the chemical reaction. For example, see, boron is there, ma. What is atomic number? 5. So how you are writing electronic configuration? 1s2, 2s2, 2p1. Okay, so now if I write, this is the nucleus. Okay, this is 1, 2, this is n equals to 1, n equals to 2, like this you are writing. Okay, so how many electrons are there in the first shell? 2 electrons. Okay, and see, this is n equals to 1. See, this is n equals to 2. So at here you have 2 s electrons, 1 p electron. Okay, so now what is the outermost shell of this boron if I ask? This is second level, this n equals to 2 level. How many electrons are there? So only these 3 electrons will participate in the chemical reactions. Okay, so now it can lose one electron or it can lose all three electrons, so that it can be +1 or it can be +3 depending upon the number of electrons lost by that atom. Okay, is this clear? Basic thing. Okay, so right, so now what you need to know here, during the chemical reactions only outermost shell electrons will participate in the chemical reaction. Remember this. Now there are some specific reactions, we are calling it as nuclear reactions, like radioactivity we listen na? So in that case we may see involvement of these neutrons and all, that inside one. Okay, but normal chemical reactions only involves electron participation. Okay, remember this. Okay, right. Next. Okay, so now why they are losing electrons or why they are actually reacting? So in chemistry everything happens to gain stability. How do they gain stability? By either losing the electrons or by gaining the electrons. Okay, okay. See, now what are the noble gases we have in the periodic table? See, now after some time we will write all the elements. Okay, just tell me now what are the elements we have here? Helium, neon, argon, krypton, xenon, radon. Okay, and oganesson. Okay, so these are the elements we have. So now whatever the elements this side in the periodic table you are seeing, all those species try to attain this electronic configuration. Okay, that's way some elements will lose the electrons and some elements gain the electrons, or some elements shares the electrons. Okay, so who will lose the electrons generally? These metals, whoever present in the S block, they will lose the electrons, so therefore they will attain this noble gas configuration. And who will gain the electrons? Someone who is very close to this, very adjacent to this, by gaining 1-2 electrons they might become like this. For example, here we have halogens. Like what are the halogens we have? Fluorine, chlorine. So these fellows always try to gain one electron from the others. Okay, like fluoride, bromide, chloride it becomes. Okay, now here also oxygen family is there. So these have 6 electrons in the valency right now. So now how many electrons are required here? See, in this valency we have 8 electrons. Okay, so it means this fellow required 2 more electrons right now. So that's why they will be in the -2 states like that. Okay, so now what is happening in chemistry? The chemical reactions are due to gaining their stability. That's it. Okay, right. Now what about carbon then? Here we have nitrogen family, here we have carbon family. See, carbon has how many electrons? 4. So generally this kind of species can also have ability to share electrons between the other elements. For example, hydrogen I am writing here. Hydrogen, how many electrons are there? Atomic number is 1. So 1 is 1. See, maximum of bonds formed by carbon is how much? 4. So that is why we are saying carbon as a tetravalent element. Okay, like that. Okay, now let's move forward. Okay, so this is the periodic table. See, in the periodic table we have how many blocks? S block, and here we have P block, and here in between we have D block, and here it is F block. So let us try to write this all the elements once. Okay. Okay. So now tell me what are the S block elements we have? Okay. Tell me. hydrogen. See, actually hydrogen you can indicate here itself also, like in the middle, because the position of hydrogen is not yet fixed. Just we are writing here. Okay, so not yet fixed means we will discuss about that later, but you just tell me the elements now. Hydrogen, let us fix it. Next, lithium, sodium, potassium, rubidium, cesium, francium. Next, beryllium, magnesium, calcium, strontium, barium, radium. Next, okay, see, here what is the atomic number of calcium? 20. So after 20 we have 21 now, so here D block will start. Okay, so do not worry, just keep it a line like this. Okay, so now lithium, beryllium is over. What is the atomic number of beryllium? 4. So after that, here somewhere over here, so we will be having now boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, hydrogen here, if you want, let us put here hydrogen for some time so that you will feel comfortable. Hydrogen here, after hydrogen, helium, somewhere over here, right now. Okay, helium. Next, lithium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, next, sodium, magnesium. Next, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium. Tell me, vanadium, chromium, manganese, ferrous, cobalt, nickel, copper, zinc. Okay, that's it. So if you know this electronic configuration, we can expect a direct question from even from this table itself. Okay, right. So after this, tell me, after this what we have? Okay, let us fill this P block first, then we'll fill this D block. Okay, so now what happened here? Boron, aluminium, gallium, next indium, thallium, nihonium. Okay, next what about this one? Carbon, silicon, germanium, tin, it means Sn. Next, Pb, lead. Okay, next what about this? Nitrogen, phosphorus, arsenic, antimony, this is Sn, Sb, you can remember, bismuth, okay, bismuth, and here moscovium, Mc. Okay, next here, this one is a flerovium. What is that? Flerovium. Next here, oxygen, sulfur, selenium, tellurium, polonium. Okay, next come here, bromine, iodine, astatine, and okay, up to here. Just tell me this one. Helium, neon, argon, krypton, xenon, radon. Okay, listen. Okay, next come to this one. Here you tell me. Scandium, yttrium, not ytterbium, yttrium. This side, zirconium. Okay, next, niobium, molybdenum. Okay, next, yttrium, zirconium, niobium, molybdenum, technetium, technetium or technetium you can say. Next, ruthenium, rhodium, palladium, silver, Ag, Cd, cadmium. That's it. Next here, these are lanthanides, these are actinides. Okay, this is S block, this is P block, done. Okay, next here hafnium, next tantalum, next tungsten, rhenium, osmium, iridium, next rhodium, next here silver, Rm, Au, gold, next Hg. Okay, just match these lines. This line is for this. Okay, next this one you tell me. See, actinium is over here, actinium is over. Next here you just remember like this, R, D, S, B, H, M. Okay, D, R, C. Okay, I will tell you. See, this is Rutherfordium. Okay, so this is dubnium. This is seaborgium, Sg. Okay, this is borium. Okay, this is hassium. This is mitnarium, Mt. Okay, and this is Darmstadium, Ds. And this one, Rg, Roent genome something is there. Okay, this one is Copernicium. Okay, Cn. Okay, that's it. Okay, now we will study about F block later. Up to here, is this clear? Okay, see, how can you remember this now? Either you practice it multiple times or you make some tricks. For example, here you can see, I will tell you like this. See, mostly don't, no need to worry about this last line. Okay, up to here you need to learn it properly. See, you just remember this 1/3 vanadium, niobium, tantalum, dubnium. 1/3. This one chromium, molybdenum, tungsten. Okay, next this one matrib. Say matrib, manganese, technetium, rhenium, borium. Okay, this one ferrous. What is that? Ferrous, ruthenium, osmium, hassium. Okay, this one simply you can remember karim, cobalt, rhodium, iridium, mitnerium. Okay, like this one nippard. Okay, it's not working there. Yeah, this one, copper. See, these are coinage elements you can easily remember copper, silver, R. And these elements also you need to get because these are last elements like zinc, cadmium, mercury and copernicium. That's it. Okay. So now these elements are considered to be 2B. What is this? 2B. This has 1B. So why this is 2B, this is 2A, this is 1B, this is 2B? Because if you write their electronic configuration, I hope you know how to write electronic configuration. So tell me, here this has a 1A we are writing, this is a 2A we are writing. Why this is 1A, 2A, this is 1B, 2B? Because if you write the electronic configuration for this, general electronic configuration you will get it as NS1. Like lithium, you tell me atomic number 3 means? 1s2, 2s1. So it is like NS1 now. Like sodium means what you are writing? 4s1 you will get. Okay. So similar to that, if you write for copper, what you are writing? Like something like 3d10, 4s1 you are writing. See, it is also having 1. That's why we are calling it as a 1b. Then next this is 2b. And this is 3b. Like that again 3b, like this it goes on. Okay, about that we will study in the periodic table once again. But today my intention is you to make clear of this periodic table. Okay, so by the end or by tomorrow's class, by the next class, you need to get this S, P and D block elements. Okay, separately we will discuss for F block later. So here we need to write F blocks. So what are these F block elements? We have 2 series, lanthanides, actinides. It means these are nothing but here. Lanthanides are here, actinides are here. Sir, you are saying here means all elements should be here only, no? Yeah, actually this is which group I am saying? Third B, 3B. Okay, so it means all lanthanides, actinides belongs to which group? Third B group elements. Okay, it means they should be like this is first group, first period, this is second period, third period, fourth, fifth, sixth, seventh. Okay, so now I will be making a question. This is a previous question itself. Lanthanides belongs to which group and which period? So third B group, sixth period. These are lanthanides. What about actinides? These are also third B group, seventh period. Okay, so these two things you should remember. Okay, after this they may also ask you about general electronic configuration of D block elements and F block elements. Direct question. These are very basic. Okay, so for today what I am giving you, the P block, I mean the periodic table, the main block. It means not F and F block, only S, P, D block. So these elements should be known to everyone first. Okay, so if you want you can write it, or we will move forward. So now let's move to the real periodic table. Here we have. So now if you observe, what about these S block elements? These are metals. What these are? Metals. Okay. So these are metals. See, after every noble gas, we are going to get a metals right now. So for example, neon. After neon, we will get a sodium. Okay. So now sodium has how many extra electrons? 1. It means extra electrons means what? If I compare with the neon, how many are there? 1. So its atomic number is? You just need to remember these numbers. Tell me, what are the numbers for noble gases we have? 2, 10, 18, 36, 54, 86. Okay, see 2, 10, 18, 36, 54, 86. So why do we need to remember that names? Yeah, numbers, because they will give, for example, atomic number 37 belongs to which group? Or which block? Atomic number 37 belongs to which block? How you are getting that? Yeah. So if it is 37, means after 36. So 36 comes here, krypton. After that, we have there. Okay. So here it is 37 rubidium. Okay. Similarly, if I ask for 34, which group element is that? Which group exactly? P block is fine. See, group numbers you know now. How many groups are there in the periodic table? There are 118 elements and we have 18 groups. 18 groups means this is as per IUPAC. Means start numbering from here. 1, 2, 3 like that, go up to there without any break. 1, 2, 3, 4, 5, 6 like that. If you see, it is up to 18. Okay, now tell me 34 I told now. 34 means 36. 2 less. 18th group, 17th group, 16th group. Means it is a oxygen family. 16th group element. Okay, like this. Okay, this is fine. Now they will give atomic number and they will ask you to get its group number and period number. Okay, this is one basic question. Okay, so now if you see, these are alkali metals, we are saying first group elements. These are alkaline earth metals. So now these are highly reactive elements in the periodic table. Highly reactive elements means what? They will easily lose electron. Okay, it means they will easily give. Why they will easily give? For example, if you take sodium, atomic number is how much? 11. So how do you write the electronic configuration? 1s2, 2s2. Tell me first of all, everyone knows how to write electronic configuration or not? Yes. Now tell me, 1s2, 2s2, 2p6. How many over? It should be 11. So 3s1. Okay. So 3s1. See, up to here 10 electrons means it is a neon gas. After that, how many are extra? 1 electron is extra. So that's why they try to lose this electron, and that's why they exist in, they will try to exist as Na plus, unipositive charge. So all these elements will exist in what charge? Unipositive, one positive charge. And what about these elements? Plus 2 charge. Okay, why? Because they are losing 1, 2 electron, they will get this configuration. Okay, now these elements are losing the electrons now, so that nature, the loss of electron nature is there now. So that is for the metals. Who will loses the electrons? Metals are electropositive in nature. What we are saying? Electropositive in nature. Okay, now sir, these are also metals only now, like D block elements are also metals. But who is more metallic in nature, they will ask. S block elements are more metallic when we compare with this D block. Why? Because they have more tendency to lose the electron. Who? This S block. And sir, between lithium, sodium and cesium, who is more electropositive or more metallic in nature? Tell me. Whether this is more electropositive or more metallic nature or cesium? Cesium. So down the group, metallic nature increases. So this is what you have studied, periodic properties now. Okay, like there is 8 marks question in your first year. Write the periodic properties, atomic radius, ionic radius, ionization energy, enthalpy, like that. Okay, so now what it says, down the group atomic radius increases. It means this is smaller size, bigger, little more bigger or more bigger, like that it goes on. Okay, it means it's a bigger size, means see, this is positive charge and size is bigger. If the size is bigger, it means electrons are very far from the nucleus. If electrons are very far from the nucleus, it is easy to remove the electron. Yes or no? So that's why down the group electron tendency to lose the electron will be more. They will easily lose the electron, they will exist in the more positive charge. So you are only stopping up to cesium. What about francium, you may ask. So francium is a radioactive element. Okay, that's why we are not discussing about that. Up to cesium only we are discussing. Okay, so in the complete periodic table, which is the most electropositive or more metallic nature element? Cesium. Okay, now when it comes to this group, halogens, what about them? They have how many electrons? See, fluorine has 9, atomic number 9. So in order to become 10, one more electron is required. So what is the electronic configuration of fluorine? 1s2, 2s2, 2p5. See, valency, how many electrons are there? 2 plus 5, 7 are there. So in order to get that octet configuration, what do we mean by octet? Octa means 8, right now. So if you write that box indication, like orbital indication, so how do you writing? This one as, this is 2s, 2p. So how many s electrons? 2. P electrons 1, 2, 3, 4, 5. Okay. So now how many electrons are required to fulfill its orbital? One more is required. So that's why they will gain 1 electron and becomes. So all these fellows will be in which charge now? negative charge. Okay, that's it. You can remember like this. Okay, next one. You know there is something called electronegativity. Means what? Tendency to attract the see, you are saying tendency to gain electron is there, no? That is called electron gain enthalpy. That is different. Electron affinity. Now what I am using? The word electronegativity. It means when you talk about covalent bonds, like HF molecule is there, or methyl chloride, methyl fluoride is there like this. Okay, see, between these two, hydrogen and fluorine, one element will be having more tendency to drag the bonded electrons. That element is considered as more electronegative. So now what is mean by electronegativity? The tendency to attract the bonded pair electrons towards itself is called electronegativity. So now the electronegativity is more for fluorine, I am saying. It means it has very high tendency to drag the bonded electrons towards itself. So I can say fluorine will be with a minus charge, hydrogen will be with a plus charge. Okay, like this you can write. So in the complete periodic table, who is most electronegative element? Fluorine, remember. So the electronegativity should be same for all the elements now, means no. Down the group size increases now, so that's why its electronegativity values decreases. So who is most electronegative? Fluorine. Who is most electropositive? Remember these two direct words, okay, two sentences. Okay, so now, okay, now slowly let me take you to organic reactions also, like what happens in the reactions. See, I am taking methyl chloride here. Who is more electronegative out of these two? Chlorine. Now what happens? See, a bond contains how many electrons? 2 electrons, right now. So now, who is more electronegative you are saying? Chlorine. So the bonded electrons are more dragging towards which side? Chlorine side. Now what is the charge it is creating on this carbon? Positive charge. See, dragging means it won't take completely, but most of the density will lies towards chlorine side. Okay, so it means most of the negative charges are dragging towards chlorine side, means it should be indicated with partial negative. This should be partial positive, like this. Okay, so now what is the charge you are creating on the carbon? Positive. See, positive charge means deficiency or rich, electron deficiency or electron richness? Deficiency. Positive charge means electron deficiency. Now see, you have studied about substitution, I mean SN1, SN2 reactions now. Let us see here. See, there is a nucleophile. It means this is positive charge now. Now what is it requiring now? It is looking for electrons because it is having some partial positive charge. Yes or no? So now what it will be looking for? If anyone who are giving electrons, it try to make a bond with that fellow, right now. So here see, I am writing something like nucleophile. It means something like OH minus or something like you can say. So what is the charge you are seeing here? Negative. So this negative charge slowly comes here because here it is positive now. See, this is slowly dragged by chlorine only. What you are creating here? So now that negative charge will come and attack over this carbon. Now what happens? CH3OH. Who is going out? Plus Cl minus. So now what you have seen? One group went out, another group joined, right now. So like you play games, right? So one fellow, like if a player is not playing good, we will substitute him. So here also I am substituting this group with another group. And what is the charges you are seeing on them? See, after removing this bond electrons, it is getting negative. This incoming group also have negative. So this negative charges are there now. So these are called nucleophiles. About that we will discuss. So one nucleophile is substituting another nucleophile. So can I say nucleophilic substitution reaction? Yeah, that's it. This is what the nucleophilic substitution. So here we have subdivided them as SN1 and SN2. About that we will discuss again. Next one is what? You have studied something like elimination reaction. It means what we are doing? We are eliminating groups from the starting material. For example, here some X group is there. Here I am writing a proton and some base, like this we have. See what is happening here, and I am heating this. Okay, so now what is happening here? See, there is a X group, X is there, so I am saying it as a leaving group or eliminating group, like that I am writing here. So now what happens, this base is there now. See, whenever you are seeing a base, so base will try to abstract a proton. It means it will try to take a proton. Like acid base means what? Acid means it releases H plus, base means it releases OH minus. So that is what neutralization reaction you are saying. So here we have negative charge now. So what it will do, this base, I am particularly mentioning it as base only. So base will try to abstract a proton. See, here we have these 2 protons, here 3 are there, hydrogens are nothing but here saying protons. Why? Because out of these 2, this is more electronegative element now. If this is more electronegative element, it will only take the bonded electrons now. If it is taking bonded electrons, what is the charge you are seeing here? Positive charge. Yes or no? Okay. So now this fellow can directly attack over here, like a substitution can take place, or it can take this proton, like proton means only H, like H plus. Now bonded electrons are there now, that will be given this side, means it will be shifting over here. Now what you are seeing? What you are seeing, tell me? CH2, this side also CH2, and there is a new bond between 2 carbons. Okay, so now what you did here, you removed X and H. So if you are removing any 2 groups from the starting material, you can say it as an elimination. See, I am eliminating these 2 groups now. So can I say this is an elimination reaction? So what makes the difference between elimination and substitution? If a group is replaced by another group, that is substitution. If an atom or group of atoms are removed or eliminated from the starting material, it's a elimination. Again, elimination reactions, we have different types like E1 elimination, E2 elimination and E1CB elimination. About this we will discuss further. Okay, then next, let's go little bit to the physical chemistry part also. When you go for a market, you will be having some apples there, or some bananas, or some eggs you are seeing there. So now they will used to sell like a dozen apples, a dozen mangoes, dozen bananas, something like they will sell right now. So dozen means what is the number it indicates? 12. It is a fixed number. Something like that. We have some other numbers like gross means 144. How much it is? So dozen, gross. These are some numbers, like words used to indicate these numbers. Similar to this, when it comes to chemistry, we will use a word mole. What is that word? Mole. So mole indicates 6.02 into 10 power 23. Very, very big number. See, 1000 means how many zeros you are seeing? Like you are writing it as 3 zeros are there. Now you should write it as 10 power 3, 10. So if there is a 4 zeros, 10,000 means 10 power 4. 1 lakh means 10 power 5. Like that we are writing. So like that, see how much big number it is. Yes or no? Yeah. So it means even if you take very small quantity of any matter, even if you take, it contains many number of atoms. Yes or no? For example, you are taking small piece of let us say coal, you know, black coal. So now that coal is nothing but carbon only now. So in that small piece of coal, there will be n number of, like lot of number of carbon atoms will be there, Okay, so it means even if you take small quantity of any chemical substance, it contains large number of atoms. Okay, in order to discuss or in order to describe about them, we are using this number mole, this word as mole. Okay, so for example, if I say 1 mole of H2 molecules, hydrogen molecules, if I say, what does it mean? This many number of hydrogen molecules will be there. See, dozen hydrogen molecules if I say. Okay, dozen H2 molecules if I say, what does it mean? I am giving you 12 hydrogen molecules. Similar to that, I am saying 1 mole of hydrogen molecules. It means, what does it mean? This is nothing but 6.02 into 10 power 23 hydrogen molecules we are discussing about. Is this clear? Okay. So this big number is there now. This number is called Avogadro number. What is that? Avogadro number. Okay, one of the very important term. Again I will discuss same thing in the mole concept, but instead of wasting the time, I just wanted to make you to go through the things that we are going to discuss in the chapters. Okay, so 1 mole of any substance if I say, means what does it mean? 1 mole of, like 1 mole of pens I am saying, what does it mean? 6.022 into 10 power 23 pens it means. Okay, so similarly if I say half mole means, half mole means, so just divide this with 2, so it means 3.011 into 10 power 23 like this. Okay, so now this Avogadro number is there now. You can use the number like indication as Na. Na indicates what? So what do we mean by Avogadro number? 6.022 into 10 power 23. Okay, now little more closer. Hydrogen molecule I am saying now. Hydrogen molecule. Okay, so how many molecule, this one molecule contain how many atoms? Molecule, I am not saying mole. Hydrogen molecule. How many hydrogen? See, a molecule will be made up of atoms. Maybe same atoms or different atoms also. Here same atoms only, no? So what are the atoms you are seeing? Hydrogen atoms. So one molecule of hydrogen contains 2 hydrogen atoms. Now you got what I am saying. One molecule contains how many hydrogen atoms? 2 So similarly, O2 I am saying ma. One molecule of O2 contains how many oxygen atoms? 2 oxygen atoms. Is this clear up to here? The term molecule is different. Now I am using the word mole. Okay. Now one molecule, 2 atoms. This O2 only I am saying. Okay. Now 1 O2, 1 mole O2 molecules. How many atoms? Is this clear what I am saying? One molecule means you are saying 2 atoms. 1 mole O2 molecules. It's very simple. Tell me. 1 mole means what? What is the number I told you? 6.02 into 10 power 23. Molecule means here how many are there in one molecule? 2. So into 2. So that is 12.04 into 10 power 23. That's it. This is the answer. Okay, do you got what I am saying? Okay. Let me take you little more deeper. This is very basic, ma'am, actually. So, okay, let's come from there to here. Okay, so one molecule of hydrogen contains how many atoms? 2 atoms. I am giving you 5 molecules of hydrogens. How many atoms? 5 molecules of hydrogen atoms, hydrogen molecules. How many atoms? So 2 5s are 10. 10 atoms you can say. Now, okay, 5 moles of H2 molecules are given. Then number of H2 atoms. So what you need to do, tell me? 5 into that. See, whenever you see mole, first what you should come into your mind? That Avogadro number. So 5 into that Avogadro number into one molecule contain how many atoms? 2. That's it. So it means what you need to do? So 10 into 6.02 to 10 power 23. So this is something like 60.2 into 10 power 23. See, 5 2s are 10, 10 into that Avogadro number. Is this clear? Very basic things. Okay. Anything you are facing difficulty to get here? No. Okay. So now, okay, nitrogen atom contains how many electrons? Tell me. One nitrogen atom contains how many electrons? What is atomic number? 7. So it contains 7 electrons, 7 protons. So it contains 7 electrons. Okay. Now, one nitrogen atom means 7 electrons. If I give 5 nitrogen atoms, 5 7 is 35, like that you are saying. Okay. Now, I am giving you one nitrogen molecule contains how many electrons? 1 into 2 into 7, that is 14. 14 electrons. Up to here it is also clear. Now, 1 mole nitrogen atom contains how many electrons? Tell me what to do. 1 mole means 1 into, means 1 nitrogen atom 7 electron into Avogadro number. So 7 into Na, that is Avogadro number, that is 7 into 6.02 into 10 power 23 electrons. That's it. Okay. Now, yeah, you can simplify that later. Okay. Now I am giving you 1 mole N2 molecules. What do you need to do? How many electrons means? 1 mole contains Avogadro number, that is fixed. Okay, multiplied with its atomicity. What is atomicity? 2. And 1 atom contains 7. So 2 7s are 14. That is what, 14 into Avogadro number. Are you getting slowly? Or still having confusions? Okay. Now I will give you some questions. Tell me otherwise. Okay. Now I am saying half mole N2 molecule contains how many electrons? Do it little bit, just one step, that's it. Everyone. Done? Tell me how to do. Half means you write half as it is. Mole means Avogadro number as it is into N2 means what? 2 into 7, that is 14. Okay, so this 2 is removed. Avogadro number means 6.02 to 10 power 23 into 7. So that many electrons are there. So 42 into 10 power 23, that's it. Okay. Now, previously when I told you about atom and its symbol, I told you how to calculate atomic mass. How to calculate atomic mass? Like number of atomic mass comes from number of protons plus neutrons. Number of protons plus number of neutrons plus protons. Okay, right. So now carbon has atomic number 6. Now what is its mass number if I ask? So 6 plus 6. So mostly like protons or neutrons are there now. Either they will be equals to number of protons, or sometimes they will be 1 or 2 units greater than protons also. Okay, so but up to 30 you will get atomic mass almost double of it. Again one more thing, see if I say carbon atomic number, how much you are saying? 6. Now what is its mass number? You will be it will be like 6 plus 6, 12 we are writing. Okay, now let us have some observation here. Now oxygen, what is atomic number? 8. And here nitrogen 7. Okay, here magnesium 12. Here sodium. Now if you if you observe this, what is the mass number? See, atomic number is 6, even number, mass is 12. Okay, here it is 8, this is also even, mass is 16. Here it is 12, mass is all these numbers are even, like these atomic numbers are even if you observe. Okay, this is general tricky way to remember, that's it. Next, nitrogen atomic number? Okay, so here nitrogen atomic number you keep it as it is. Sodium 11 I am saying. So what is its mass number? 23. Lithium atomic number is 3. Mass number 7 you are getting. It means most of the cases whenever you have odd atomic number, it will be something like this. 2 into, like here what we did, 6 plus 6, no? Here also atomic number 11 plus 11 plus 1. So like 22 plus 1. It means you just need to add 1 extra. It means 1 neutron is more in these cases. Okay, here also. So 3 plus 3 is 6, 7. So this will be seen in most of the odd number cases. Even number it will be mostly double it, that's it. Okay, so for neutron it will be again 14. So what I am saying, this is not a concept or not, like that. It's just a tricky way to remember. See, it is not working for nitrogen. So that's why I am saying just a simple tricky way to remember that even number means you just double it. Atomic number you double to get the mass number, atomic mass. Okay, in case of odd number cases, double it, add 1, that's it. Okay. Next one. Can you do this? What is the mass number for this molecule C2H5OH? What is the mass number for this? So how many carbons are there? 2 into 12. See, you did here 12 plus hydrogens 5 plus 1, 6 into each hydrogen atomic mass is only 1. Why, sir, you are saying hydrogen atomic mass is 1? Because its atomic number is 1. It should be 2 now. Why you are saying only 1? Because atomic mass is what? Sum of neutrons plus protons. But hydrogen does not has neutrons. It has only proton. So that's why its mass number is 1. Okay, actually, like see, when you extract, see, all these elements are occurring from nature only now. They will be extracted from the nature, from some sources like carbon by mining and all. So if you say, if you are extracting carbon from earth crust or wherever it is, so you are going to get 3 elements here. Three things here, 3 species here. So carbon, 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 all of them are carbons only. Atomic number also fixed, like 6 6 only. But here it will be 12, it will be 13, it will be 14. So now how do they differ here? Number of protons are same or different? Same. Electrons also same. But what they differ in? Mass number. So that mass number is differed because of neutron difference. Here, see, 12 is nothing but 6 plus 6 na? 6 protons plus 6 neutrons. Here also it is 6, means what is that extra 13th number? That is neutron is extra. So 7 neutrons, 6 plus 7. Here 6 plus 8. Okay. So these are called what? Isotopes. What is this? Isotopes. Okay. Right. So now, whenever we say atomic mass, see, we are not dealing with these things generally. We are just saying carbon means C12, like that only we are using. But whenever we say atomic mass, it's a combination of all these species. Combination of all these species. But in the nature, if you extract, this will be around 99% I can say, or more than that. Okay, so this will be like 98 point something like 9 or something like that. This is around 1.1% like that. Okay, so it means the percentage abundance, it means if you extract 100 grams of this carbon, it contains how many grams of C12? Almost 98.9 grams will be C12 only. Only 1% or 1.1% of C13 and very minute quantities of C14. Now, if I say mass of C, carbon, so it is nothing but average mass of all these isotopes. Okay, but who is dominating here? C12. So that's why it will be like around 12 we are taking while doing the calculation. Okay, it should be like 12.008. That extra decimal numbers coming now. From where it is coming? It is from 13, 14. That extra parts are there, like 1 extra neutron, 2 extra neutrons, like that. So that is what we actually need to write 12.008 like that, but we are making it as 12 only. Okay, so when it comes to hydrogen, hydrogen also has 3 isotopes. One is hydrogen 1 and another one is called deuterium. It means that is also hydrogen only. Here you can write 1, protons are same, but neutrons are 2 here. I mean mass is 2 because 1 proton and 1 neutron, that is 2 here. And when I write one more hydrogen here, 1, here I am writing 3. It means what it is saying, tell me? Protons are 1 only, but neutrons are 2. So this is, what is the number you are seeing here? 3. So it should be indicated with symbol T, tritium or tritium. Okay, this one, what is the main number here you are seeing? 2. Deuterium you should say. What is that? There is a 4 marks question in your hydrogen chapter. Heavy water you are writing. Write the applications of heavy water, something like that. You will see the question, one question. Okay, okay. So that is deuterium here. Okay, this one should be called as a protium or proton, protium. So that is nothing but our hydrogen generally. So whenever we say hydrogen, it is a combination of 3 things. But who is dominating? Hydrogen. That's why we are taking it as almost as 1 here. Okay, place. How many oxygens are there? 1 into 16. Now add this. So 24 plus 6 plus 16. So 30 plus 16, 46. Like this you can do. Okay, now tell me for sulfuric acid. You are much familiar with this sulfuric acid. Tell me, what is its molecular weight? What is the molecular weight? 98. How you are doing? 2 into 1 plus 1 into 32 plus 4 into 6. See this, what is this 2, 4 I told you? Atomicity I told now. So the 2, that atomicity into 2 into 1 plus 1 into 32 plus 4 into 16. So it will be giving you, 98. Okay. So like this you can do for nitric acid, you tell me. And next C6H12O6, you tell me. Tell me here for these two. So this one is very simple, 1 plus, say 1 into 1, this one 1 into how many nitrogens? 1, 14 plus 3 into 16, so 48 plus 14 plus 1, how much? 63. Okay. Next this one, this is what? I mean glucose. Okay, the next one, okay, let us discuss few things about. Till now I used a word, molecular weight. What I used the word? Molecular weight. Now I am using one more word, molar mass. See, this is nothing but mass, molar mass. What do we mean by mole? Avogadro number. If I take 1 mole of any substance and if I keep it on the weighing bar, weighing machine, whatever the mass we will get now, that is called molar mass. It means the mass of 1 mole of any substance is called its molar mass. Molecular weight means mass of that molecule only. Molecular weight means, for example, molecular weight of CO2, if I say, the mass of one CO2 molecule. If I say molar mass, the mass of 1 mole of these molecules. Okay, you got very small difference is there. If I only weight take this molecule, it is considered to be molecular weight. Only one molecule means molecular weight. If I say 1 mole of molecules, molar mass, that is the difference. Okay. Okay. See, now whenever they mention molecular weight, you just mention it as 44. Okay, and its molar mass means 44 grams, you just mention. It means what is the molar mass of CO2 if they ask. It is a 44 grams, you can say. Molar mass of CO2 means how much you are saying? 44 grams. Okay, so this 44 is nothing but this is the mass of 1 mole of CO2 molecules. Okay, how many molecules? If I take 1 mole of CO2 molecules, how much we will get? 44. So how we are getting exactly like this means it will be like 12 grams for carbon and 2 into 16 grams for oxygens here. So overall 32 plus 12, 44 grams. Whenever I use molar mass, what is the unit for molar mass? Gram per mole. It means per mole of substance, how many grams it is. If I take 1 mole of that substance, how many grams it should be? That is considered as molar mass. Okay, so that is what the unit. So if I say 1 mole CO2, what is the weight of the CO2 now? 1 mole CO2 means how much you should say? 44 grams. Okay, now one simple question. 1 mole CO2 contains how many grams of carbons? 1 mole of CO2 contains how many grams of carbon? 12 grams. Okay. Now, 1 mole CO2 contains how many moles of carbon atoms? 1 mole CO2 contains how many carbon atoms? 1 mole. See, 1 mole ante you just take this formula first. CO2 you are writing now. In 1 CO2 unit, how many carbons are there? 1. If I take 1 molecule of CO2, you will have 1 carbon atom. If I say 1 mole CO2, it also contain this 1 only now. It means that should be multiplied with mole. It means you should say 1 mole of carbon atoms are present in 1 mole CO2. Okay, and how many moles of oxygen atoms are present? 2 moles. Means 1 mole CO2 contains 2 moles of oxygen atoms and 1 mole of carbon. Is this clear? Yeah. Let's move little bit deeper. Okay. Let me, okay. కొందరికి అర్థం కాకపోవచ్చు ఇది ఒక దాంతోటి ముగిద్దాం. Okay. Hydrogen molecule I am writing. So 1 mole hydrogen molecule, if I say, how many hydrogen molecules how many hydrogen atoms we have? 2 moles of hydrogen atoms. That's why I told you this is called atomicity. Whenever they ask for atoms, moles, number of moles into that atomicity. How many moles are given? 1. What is the atomicity? 2. That's it. 2 moles of hydrogen atoms you will get. Okay, is this clear? Okay. Now 1 mole H2 means how many grams? 2 grams. Okay. Now let us little more. Now I am giving you 10 grams of H2. How much I am giving you? 10 grams H2. How many moles of H2 is this? How do you do this? See, ఇక్కడ పైన లైన్లో మీరు ఏం రాశారు? 2 grams of H2 means you told it as 1 mole. Now 10 grams I have given. How many moles I am asking? 5 moles. How do you do this? How do you do this? See, just 2 is becoming 10. It means with what number I have multiplied? 5. If you are multiplying here with some number, here also you multiply that. So 1 into, here 1 is there, 1 into multiplied with 5. So means this value is 5. That's it. Or let us make a formula here. Okay, what we need to find here? X. So X will be equals to, okay, or X, we need to find this X now. So X, like multiply this X with 2. So 2X is equals to this 10 with 1. See, this is 2 grams now. So 2 into X equals to 10 into 1. So 5. So X will be now how much? 5. So you got 5 moles now. So that's it. So this method is called a unitary method. What is this? Now, once again, let us make one formula here. See, what we are finding here? moles, right now. So X means what? Number of moles we are finding. So number of moles is equals to, okay, so what we did, see number of moles is equals to 10. So 10 is what? The given weight now. How much weight I have given? The question previously 10 grams of H2 is given. Tell me number of moles I asked you right now. So number of moles equals to given weight. What is the given weight? 10 grams by, with what number you divided? 2. So 2 is nothing but its molar mass, right now. So given weight by its molar mass gives you what? Number of moles. Now given weight is how much? 10. What is its molar mass? 2. Fine. So from now onwards, if someone asks you, by giving you the weight of a substance, they will ask you number of moles. What you will do? Given weight by its molar mass. For example, I am giving you now 22 grams of CO2. How many moles? 22 grams of CO2. How many moles it is? Half mole. So how do you do that? N is equals to given weight by its molar mass. Given mass by molar mass. What is the given mass? Molar mass of CO2 is how much? 44 gram. Molar mass units are gram per moles. Okay, gram cancel. Okay, 22 2s are 1 by 2 mole. So this is half mole of CO2. Can we say like that? Yeah. Okay. Now one more simple question. How many grams of CO2 I given? So 22 grams question I have given. So how many grams of carbon is there in this and how many grams of oxygen is there out of this 22 grams? 22 grams of CO2 we have. Then how many grams of carbon, how many grams of oxygen is present in the given 22 grams? Oxygen atoms, let us write oxygen. Okay. Do you got the question? In order to get this 22 grams of CO2, how many grams of carbon, how many grams of oxygen is there present in this 22 grams? How do you do this? It's very simple. First you find number of moles. How many moles you got? Half mole of what? Half mole of CO2 you got. Okay. Just now I told you 1 mole CO2 contains how many moles of carbons? 1 mole carbon, 2 mole oxygen atoms. Okay. Similarly, here if it is 1 mole you got like that. Here it is how many moles? Now what you will do? Half mole carbon, 1 by 2 into 2 oxygens, 2 moles of oxygen. So 2 cancel, so you will get 1 mole oxygen atoms, half mole carbon. So half into, what is the molar mass of carbon atom? Like atomic mass of carbon atom? 12 grams. So 6 grams of carbon is present. Here 1 mole you got now, 1 into 16 grams of oxygen. So this is 16. So total mass is how much? 6 plus 16? 22. So we got our 22. Is this clear what we are doing? Okay. Yeah. So you can write this example.
Can we directly put 22 by 12?
No, see 22 by 12 means nothing you will get. Okay. So why you got that thought into the mind? First tell me. Like ala
గ్రామ్స్ ఇచ్చినప్పుడు దానికి మోలార్ మాస్ కి చేస్తున్నాము డివైడ్
hmm.
like x value there's 22 right
Hmm.
CO2 so given by total
See, you have 22 grams as a given weight. Wanted to do do these small questions. చాలామంది స్టూడెంట్స్ మైండ్లో థాట్ ఏముంటుందంటే we don't know basics. Here also they are asking, sir, can we prepare it from zero level? ఈ ఆలోచనతోటే బతికిపోతూ ఉంటారు, ఎగ్జామ్స్ కూడా అయిపోతూ ఉంటాయి. సో మన కాన్సెప్ట్స్ ఏం రావనుకుంటారు. బట్ వాట్ ఎవర్ యూ నో దట్ ఈస్ ఎనఫ్. యూ స్టార్ట్ సమ్హౌ. ఓకే, సో slowly it will comes into your results, like it will be seen in your results, but not suddenly, like, but as you keep on working it will be improved. Okay, first 1-2 days ki ravalante dan kashtam. Okay, tell me, how can you solve this? So how do you did this? Number of moles of CO2, number of moles in 28 grams of nitrogen atoms. Okay, number of moles in 28 grams of nitrogen atoms. So question it is different. Nitrogen atom it mentioned. So for nitrogen atom, what is its molar mass? 14 grams. Okay, so it means you can say 28 by 14. So it should be 2. Okay, is this clear first of all? Okay, now I will be making same question here. You can see number of moles in 28 grams of nitrogen. I'm not mentioning anything. Nitrogen I'm writing like this. So what is the answer? By default you should understand that nitrogen means in the nature how it will be? It will existing as N2 now. So it should be considered. Nitrogen means N2. If I say oxygen, O2. In that case, what happens to the molar mass here in this case? 28 it becomes right now. So answer changes. Okay, if they mention nitrogen atom, this will be the scenario. If they only mention nitrogen, so number of moles will be given weight by its molar mass. So it will be 1 mole. Okay, got the difference? Small difference is there. Okay, but it makes the confusion for most of the students. Now tell me for this, the mass of 2 moles of nitrogen atoms. See, 2 moles of nitrogen. So for 1 mole of nitrogen atom, 14 now. So 2 into 14. That's it. Do this. Answer me. The number of moles in this number of nitrogen atoms. Okay. Now how you get this? When they say number of moles, atoms, number of atoms they are saying, moles, atoms they are saying. So what you have the relation between moles and atoms are entities? What I told you, 1 mole means how many atoms I told you? 2. Avogadro number I told you. So 1 mole of any species contains Avogadro number, that number 6.022 into 10 power 23, like this number I have mentioned. Okay. Now here they are asking us what? Number of moles by giving us 12.044 into 10 power 23. Now what to do, tell me? I want this n value. I told you that unitary method, na? What is that? This number into this number into this gives you n into 6.022 23 into 1 right now. So how many times? See, 10 power 23, 10 power 20. This is almost 2 times. So how many moles we got? 2 moles. Okay. Now here you can make one formula from this. Number of moles is equals to, this formula will be useful when they give number of atoms. Okay. Given number of entities by Avogadro number. What is this given number of entities means? How many these numbers atoms are given? Entities means it can be atoms, molecules or anything. Okay. It means the given number by Avogadro number gives you number of moles. Okay. This is one more formula. You have got 2 formulas till now. One is number of moles equals to given weight by its molar mass. One more is given number of entities by next, can you do this? Yeah. One last question. With this we will wind. How many atoms of oxygen are there in 16 grams of oxygen? Oxygen. Now what I told you, oxygen means what you need to know here? Oxygen. Is it O2 or O? Now tell me, how many atoms of oxygen are there in 16 grams of oxygen? See, first find from the given weight. See, if I give you some quantity, like some weight I am giving you, directly tell me how many atoms are there means will you count that? Is it possible? It's highly difficult. Now what to do? Convert into number of moles first. How do you do? Number of moles equals to given weight by its molar mass. Tell me, 16 by oxygen O2. So 32. So this is 1 by 2. Now you can able to do now. Half mole we got now. So half mole, 1 mole means Avogadro number. Half mole means half into that Avogadro number. 6.022 into 10 power 23. So it will be 3.011 into 10 power 23 oxygen, like what we got here. See, this many number of moles of oxygen molecules we got. What we got? See, what we calculated here, number of moles. See, they are talking about how many atoms of oxygen are there in 16 grams of oxygen. 16 grams of oxygen means, tell me, 16 grams of O2 it is right now. So 16 by 32 means half mole of O2. right now. So half mole of O2, up to here it is perfect. Half mole of O2, it is perfect. Now what they are asking, how many atoms are there asking? How, what we got? Molecules we got. So if they ask for molecule, you should say like any number of O2 molecules will be there. But did they are asking for atoms or molecules? Atoms. Now one molecule contains how many atoms? One molecule like O2 molecule contains? So half into number of atoms equals to number of moles. This means number of moles into Avogadro number into atomicity. So number of moles, how much we got? Half. Na means? Next, atomicity is how much for O2? 2. That's it. So 2 cancel. This is the answer. Okay. So this is the value they ask for number of molecules. This is the answer for number of atoms. Okay. You got the difference, right? Okay. That's it. Okay. The remaining things we will discuss in the next class. Okay. And one more thing here, if you want, you can practice these questions, and they will give you the materials. From that also you can start solving the questions. Okay. Do not look for any other thing. Okay. You start whatever the material you have, you just open it, do some questions. Okay. That's it. Any doubts are there?